All right, let's move on. Okay. Right, the cancellation of the Wimbledon tournament has led to a world surplus of tennis balls, and Santa has decided to use them as stocking fillers. Okay, they do like to be current with the times here. He comes down the chimney with n identical tennis balls, and he finds k named stockings waiting for him. Let G n k be the number of ways that Santa can put n balls into k stockings. For an example, G22 equals 3, because with 2 balls and 2 children, Miriam and Adam, it's those guys again, he can give both balls to Miriam or both to Adam, or he can give them one each. Okay, fine. What is the value of G1k for k is greater than 1? Well, he has one ball and k children, so he can give the ball to any one of those children. So if it was like A, B, C, and D, he could give the ball to any one of those 4. So it's just k. It's equal to k. So if k is 4, it would be 4 options. If k is any number, it would be that number of options. Okay, what about if he has n balls and just one child? Well, he has only one choice. He gives all of the balls to those children, so it's just 1 to that children there. That child gets all of the balls. That's the answer. Okay, if there are n greater than 2 balls and k greater than 2 children, then Santa can either give the first ball to the first child and distribute the remaining balls among k children, or he can give the first child none and distribute all of the balls among the remaining children. Use this observation to formulate an equation relating g and k to other values taken by g. Okay, this needs a little bit of thinking about. So if he can either give the first ball to the first child, then distribute the remaining balls among the k children. So if he gives the first ball to the first child, then he would have n minus 1 balls, and then he distributes those n minus 1 balls between the k children. It doesn't mean because he gave the first ball to the first child, he won't give them any more, tennis balls. Or he can give the first child none. And that's like the other option, right? You either give the first ball to the first child and then redistribute the rest of the balls, or you say, right, that child gets 0 tennis balls. So if you do that, then you have sort of one less child and you still have n of the balls. So one less child and you still have n balls. So this is what you've said, basically. You've said that you either have, so you either give that first child some balls or you give them no balls. And that's sort of a binary option. You can't have anything else. So this must be true. This must be a relationship that is true. Okay, so part 4, what is the value then of G75? Right, okay, so we're going to have to do this again and again and again to get down to numbers that we could possibly work out. So we do already know G22 is 3. Okay, so maybe we can get to there. So let's do that. So let's go G75 is equal to G of 6 and 5 and plus G of 7 and 4. Okay, that's all right. So then if we go to the next line, so G of 6 and 5 becomes G of 5 and 5, and also G of 6 and 4. Okay, and then we're going to get another G of 6 and 4 from here, and also a G of 7 and 3. Oh my, this is going to take forever to get to the bottom, I think. So we might want to get down to a place where we can reasonably work out some combinations. So I'm just going to call that 2G of 6 and 4. So then we have G of 4 and 5 plus G of 5 and 4 plus 2 times G of 5 and 4 plus G of 6 and 3. Okay, that's inside my 2 times bracket. Plus G of, again, that's another 6 and 3, and G of 7 and 2. Okay, I'm going to rewrite this. Good job they give you plenty of room. Um, so we only have one G of 5 and 4. Oh, we saw 4 and 5, sorry. G of 4 and 5 we only have one of. But we have three G5 4s. Okay, so we have three G5 and 4. And we also have three of G6 and 3. I think I'm seeing a kind of Pascal's triangle thing go on here because I've got a 1, 2 from the previous one, and now I'm going to have 3 3s. Maybe the next one I'll have some 4s and 6s. There's probably like a really clever way of working this out straight away, but I don't know it. So if you do, maybe comment below. There we are. So there's that. Okay, so the next step, G of 3 and 5 plus G of what's that going to be? That's going to be 4 and 4. Okay. Plus 3 times G of 4 and 4. Plus, okay, so G of 5 and 3 plus another G of 5 and 3. Okay. Okay. Plus G of 6 and 2. Okay, that's all in the brackets. Okay, and then plus G of 6 and 2 plus G of, okay, 7 and 1. And this is the first time we've got a 1 in either of the positions. So G of 7 and 1 is 7 balls given to one child, so there's only really one way of doing that. Okay, so we can actually say that this is just 1. Okay, so let me rewrite this as G of 3 and 5 plus 4 times G of 4 and 4 plus, which one, there's probably another one that has a 4, yeah, so this 6 and 2 has a 4, plus G of 6 and 2 has a 4. So even though I'm probably not doing this the optimum way, there is something that's quite helpful here, which is that I can see that I'm on the right track if I have the Pascal's triangle numbers, right? I've got a 1, 2 4s, and now I've got a 6 because I've got a 5 and a 3 inside here, so that's 2 times 3. So 6 times G of 5 and 3, okay, plus, do I have a 6 and 2? I've done my 6 and 2, so plus 1. Okay, maybe I'll do this just sort of a couple more times, and then I'm going to try and work them out. So G of 2 and 5 plus G of 3 and 4 plus 4 times G of 3 and 4 plus G of 4 then 3 plus G of 5 and 2 plus G of 6 and 1. Okay, there's another 1, and that's inside my 4, plus 6 times G of 5 and 2 plus G of 4 and 3. Okay, 4 and 3. Lovely. Okay, so if I neaten this up a little bit, I've got G of 2 and 5, 3 and 4, so I have 5 of them. Okay, so let's just check I've got my Pascal's triangle numbers. So 5 of G and 3 and 4. Okay, and then I have a 6 of 4 and 3 here and a 4 of 4 and 3 here, so that's good. I've got a 10 of G 4 and 3 plus, I should have another 10, hopefully. Yeah, so there's a 4 of 5 and 2 and a 6 of 5 and 2. So, that's a 10 of G of 5 and 2. Okay, and then I need another 5 plus 5 of, let's have a look. Yes, there's a 3 and a, no, we've done the 3 and 4. 6 and 1, maybe? Yes, actually, okay, so we had that +1 from last time, right? I forgot to add this +1 here, but I now have a 4 of G and 6 and 1, and I have that 1 on the outside, so it's just +5, okay? So I've got this feeling that if I carry on much longer, I'm going to make a mistake somewhere. So I might want to try and work out what these are at this point. So G of 5 and 2 means I have 5 children and 2 balls. So I'm going to have 2, 0, 0, 0, 0, and then I'll have my 2 in this position and my 2 in this position. So in fact, I'm going to have 5 different positions for my 2 with all zeros. Okay, so something like this. These are some options, right? Not all the options yet, but just some of the options. Okay. But you can only split it into 2s or 2 1s, right? So the next options are just 1 1 and then 1 2 3, or 0 1 1 1 2, or 0 0 1 1 1. So just try your best to be logical here. 0 0 0 1 1. Okay, so those are 4 more options with the ones in right next to each other. Right, and the last one is when the ones are in different positions. So I might go 1 0 1 0 0, or I'll go 1 0 0 1 0, or I'll go 1 0 0 0 1. Okay, so that's with holding one of my ones at one end. Okay, then I can start to move this one along. So if I go 0 1, then I can have 0 1 0. Okay, or I can have 0 1 0 0 1. Have I had that one before? Just checking. No, I haven't. Okay, I can't have them next to each other because that's not allowed. Now, do I have all of the options here? I'm just checking. No, I don't have 0, 0, 1, 0, 1. Okay. So this is G of 2, 5 I'm working out here. It might have been smarter to go one lower maybe. But let's hold on for a second because timesing by 5 and timesing by 10 is pretty easy. So maybe that's a concession that you can make here. So have I got any more? I need to just make sure. I think we're okay because what's that going to give me? Is that going to give me... So there are 5 of these, there are 4 of these, and there are 6 of these. I'm just checking if I've got any other combinations of 2 zeros in different positions. So yeah, I think that's it. I think that's it. Yeah, I've got them all here. So that is a total of 15. So this one here, I'm saying is 15. So some of these might be a little bit easier. So distributing 3 balls among 4 children, that could be 3, 0, 0, 0, or 0, 3, 0, 0, or 0, 0, 3, 0, or 0, 0, 0, 3. And then there are 3 ones, 1, 1, 1, 0, or 1, 0, 1, 1, or so I'm just going to redistribute the 0 here. So let's call it 1, 1, 0, 1, or I think there's one more. Yeah, 0, 1, 1, 1. Okay, so 4 of them, that makes 8. And then there's a 1 and a 2. Okay, a 1 and a 2. So then I could have, let's fix the 2 and go 2, 1, 0, 0, or 2, 0, 1, 0, or 2, 0, 0, 1, or those are the 3 with the 2 at the front. Okay. So maybe I can put the 1 at the front and move the 2. So that is 1, 2, 0, 0, 1, 0, 2, 0, 1, 0, 0, 2. Okay, there's another 4 there. So what about the 2 and the 1 being in the middle or something like that? Okay, it's quite a lot actually. Maybe I should have gone 1 lower. So there's 4 there, there's 4 there, there's 3 of these, there's 3 of these. Okay, can I go again for this? think there should be some more options. There's certainly the 2 and the 1 in the middle. So let's do the ones where 2 and 1 are next to each other. Okay, so 0, 2, 1, 0, or 0, 1, 2, 0, or 0, 0, 2, 1, or 0, 0, 1, 2. Okay, and there are 4 of these. So what have we got here? Are there any others that I've missed? That's the problem. You're always wondering if you've missed some. Okay. What about if I don't have anything in the first position, but they're not together? Yeah, I haven't got those. So I've got 0, 1, 0, 2. I haven't seen that one before. No. And I have 0, 2, 0, 1, and then 0. I can't have any together. Is that it? Yeah, I think that might be it, because can I put 1, 0, 0, 1? Okay. Yeah, so there's only 2 more there, I think. So what does that make? 2 plus, that's 6, that's 12, that's 8, that's 20. Okay, so that's 20. So I've got 5 times 20 here. Okay, and then 4, 3, so that's 4 children and 3, 4 children, no, sorry, 4 balls, 3 children. So 4 balls, 3 children. That should be a little bit easier. So you could say you give 4 to one child. So there's that, and there's that. Okay, and then you give maybe 3 and 1. Okay, so we could go 1, 3, 0, 1, 0, 3, 3, 0, 1, or 3, 1, 0. Okay, are there any other options? 0, 1, 3, and 0, 3, 1. Okay, have the zeros been in all the positions twice? That's a good check. Yes, they have. So there's 3 of those, there's 6 of those. Okay, and then how about 2 1s and a 2? So 1, 1, 2, 1, 2, 1, 2, 1, 1. Is that it? Yes. Okay, there's 3 of them. So that makes 12, and I think that's it. Okay, so there are 12 of those. Okay, so 12 of these. All right, 5 and 2, and then 2 and 5. Okay, sorry, I've done 2 and 5. No, 5 and 2 is the last one, and then I've just got to add 5 on the end. So 5 children, just 2 balls. That shouldn't be too bad either. So let's say we give 2 to each one. So 5 children, no, sorry, 5 balls, 2 children. That's what it is, isn't it? I've just done 2 balls, 5 children. Yeah, okay, so 5 balls, 2 children. So I can either give 5 to one or 5 to the other one, or I could give one of them 4 and the other one 1, or the other one 1 and this one 4. Or I could give one of them 3 and the other 2, or the other one 2 and this one 3. And I think that's it, right? Yeah, that's it. So that's 6. Okay, so that's 6 for this one here. Let's hope this works out. So looking at this now, I've got 15 plus 5 times 20, that's 115. Plus, so I'm going to write that down, 115 for this one and this one, plus 10 times 12, which is 120, plus 10 times 6, which is 60, plus 5. Okay, so that makes so this makes 120, that makes 240, that makes 300. Okay, sorry, it's 300. So am I on the right track? I think I might have made a mistake somewhere. 5 and 2, 2 and 5. Okay, I think I've made a small mistake somewhere here. Now this is a tough question. Maybe I should have gone one level lower. So where have I missed out? So 2 balls among 5 children. I think I've got that one right. I think I've probably the error is either in my 3-4 or my 5-2. So let's have a look at the 3-4 again. So we've got 4 children and 3 balls. Is that right? No, 4 balls and 3 children. Okay, I think that's certainly right. 5 balls, 3 children, 5 balls and 2 children. 10 times 5 balls and 2 children. Okay, where is my error here? Okay, maybe I should go back to this at the end. Because I'm going to need it for this last part here. After the first house, Rudolph reminds Santa that he ought to give at least 1 ball to each child. So in fact, G of H7, which is with this restriction, you just take away K from N. So this is always going to be just G of 2, 5. And I have G of 2, 5 in my solution, so maybe I should just check my G of 2, 5. I can actually do my rule with G of 2, 5. So if I'd use G of 2, 2, 5, I could say that that is G of 1, 5, which is just 5, plus G of 2, 4. And G of 2, 4 is going to be G of 1, 1, 4 plus G of 2, 3. So 1, 4 is just 4. 2, 3, we can do that again. That's going to be G of 1, 3, which is just 3, plus G of 2, 2. G of 2, 2, we were told that's 3. Okay, so that makes 6 plus 4, that is 15. Okay, so the last question, the answer is 15. And now I've checked this step here. That's 15 for certain. G of 3, 4 is 20. That's possibly where I'm making a small mistake. Or maybe it's here, G of 4, 3. So I'm going to work out G of 4, 3. I'll do all of these separately. G of 4, 3. What's that going to be? That will be equal to G of 3, 3 plus G of 4, 2. Okay, which is equal to G of 3, 2 plus G of 2, 3 plus G of 3, 2 plus G of 4, 1. Okay, so G of 4, 1 is just 1. And then it's 2 G of 3, 2. So 2 times G of 3, 2 is G of 2, 2 plus G of, so G of 3, 2, we could also call that G of, that would split into G of 3, 1 as well. So that's these two, plus G of 2, 3, which we could write as G of 2, 2 plus G of 1, 3 plus 1, plus the 1 on the end. Okay, so we've got 1 ball to distribute between 3 children, so that's 3. We've got 2 balls to distribute between 2 children. That is 3 options as well. So that is also 3. And then 3 balls with 1 child, that's 1. So that's 2 times 4 plus 3 plus 3 plus 1. Okay, 2 times 4 is 8, plus 6 is 14, plus 1 is 15. Okay, I've checked that now. So is that what I got? No, I got 20 there somehow. So do I believe my answer? No, that was G of 4, 3, right? G of 4, 3, I got 12, so it's actually 15. Okay, so that's where my error is. So if instead this was 15, so 10 times 15 is instead 150, so you have to add an extra 30 on, so it's 330. Okay, so sorry about that, made a small error there. I probably should have split a lot of these down, but I thought I could maybe, there might be an easier way to sort of just work it out by hand, but no, it is quite hard. So maybe there's a rule for you, split it down to as low as numbers as you can before you try and do it by hand.